Hi, my name is Joe Chacon. I'm an electrical engineer with Padge LLC. This is the third of several videos about harmonics. Today, I want to talk about the effect of high harmonics on conductors and give an example. Our first video introduced an example waveform of 480 volts AC with 3% on the fifth harmonic, 2% on the seventh harmonic, and 1% on the 11th harmonic. Remember, the waveform looked like this. And remember, the THDV plot looked like this. We calculated our THDV to be 3.74%. Let's expand this example further. Let's assume we're connecting our 480 volt AC three-phase source to a load that draws a resistive 260 amps. And we want to use 1,000 feet of a 4-aught copper conductor. I'm not going to show you here how to calculate the ampacity of 4-aught, but let's assume it meets all the criteria to be rated at exactly 260 amps. You can start with table 310.16 in the NEC code to look this up, but keep in mind there are lots of factors when calculating ampacity. Let's assume that the resistance of this 4-aught conductor is 63 milliohms and the reactance is 51 milliohms or 0.1353 millihenries. I get this from table 9, National Electric Code. Okay, hang with me here on the math. I'll try to make it as simple as possible. Let's draw the circuit first. I'm doing one phase of analysis with the resistance and inductance of the wire shown, and the load shown is 1.01163 ohms. Now we use Ohm's law to calculate the current for the fundamental and each harmonic. Let's start with the fundamental of 60 hertz. The impedance of the 4-aught conductor at 60 hertz is 0.0811 ohms. The load resistance is 1.0116 ohms. The total impedance is therefore 1.065 ohms by some fancy math I'm not going to show here. Ohm's law says to divide the voltage by the impedance to get the current. 277 volts is our line to neutral voltage for our fundamental frequency. 277 divided by 1.0654 ohms is 260.00 amps. Let's move on to our fifth harmonic now. Recall, it is 3% of fundamental from our example. 3% of 277 volts is 8.31 volts. Please pay attention here. The impedance of the 4-aught conductor at 300 hertz, which is the fifth harmonic, is 0.2627 ohms. That is higher than 0.0811 ohms, which was the 4-aught impedance at 60 hertz. Why is this? Inductance might be a fixed value, but reactance is not fixed. Reactance is 2 times pi times the frequency. Now, let's use Ohm's law to calculate our current for the fifth harmonic. 8.31 volts divided by 1.0943 ohms is 7.59 amps. I omitted some fancy math here again. If we were to repeat this process for the 7th and 11th harmonics, we would see the 4-aught conductor total impedance is to be 0.3626 ohms and 0.5646 ohms respectively. We would see the total current for the 7th and 11th harmonics to be 4.94 amps and 2.30 amps respectively. By the way, I'm doing all this math in Excel to show that it is quite feasible without fancier computational software. I have the THDI plot shown here. I put everything in this chart too. This looks pretty benign, right? Well, let's sum them up and see how benign they really are. Remember, from the first video, I said the summations are the sum of the squares of the individual components. We then take the square root of that sum. So we'll add 260 squared to 7.59 squared to 4.94 squared to 2.30 squared, and then take the square root of that sum. I've been rounding within this video, but I've been keeping track of significant digits for the math in Excel. The total current for the fundamental in all these harmonics comes out to be exactly 260.17 amps. The fundamental was exactly 260.00 amps. So this is benign. The harmonics only add 0.07% to the current. Remember, from the first video, I mentioned that IEEE 519 wants to keep total harmonic distortion to less than 5%. The THDV for this example is 3.74%. I say this to say we knew in advance that harmonics would have a benign effect on the conductor sizing. All right, just for kicks, let's assume our fifth is 30%, our seventh is 20%, and our 11th is 10%. How much current will we draw at this point? The answer is 276.28 amps. Our 4-aught conductor will overheat for these conditions because we know its ampacity is only 260 amps. I hope it is a bit clearer as to how harmonics can change the current and must be considered or even mitigated. I hope this knowledge can help you become the harmonics guru in your company. Please look us up at padge.org. That's PADGE.org if you need anything on this topic or others. The next video will look at how harmonics affect transformers.